Hey guys, and welcome back to my channel. Alright, so I just want to point out a few interesting things I've noticed. I've started tearing this power supply down. I've just put this edge connector back on just to show you something. But first of all, the dials on the front, sorry, the switches that just go between amps and volts on the two panel meters, you'd expect them to be exactly the same, right? That one has got 4 wires plus 2, 6. Alright? That one's only got 5. If we look at the wiring loom, and I'm not talking about the tie, the wire wrap to tie it up. Look, there's a green and yellow wire sticking out there. It's cut. There's a pink one there. If we look down here, the green and white one comes out down here. If I take this edge connector off and have a look at in the other side, there's the end of the pink one. That again is just wire tie. That's just wire tie. So, and then in here, there's a purple one. Just there, end of my finger. So, okay, there's wires cut in the wiring loom. And at first I thought that was factory, but then when I counted how many wires go to that switch compared to that switch, then I noticed that this one, how am I going to get this to focus? There you go, you can see it. That's been soldered to before. That hasn't. That hasn't. Unless it's been perfectly cleaned off somehow. Although it would kind of make sense because there are 3 wires that have been cut. Are they all at different lengths? Huh. They are, but they don't really line up with where the connectors are. Sorry, I realise I keep putting the phone down. I'll get this up on the bench in a minute. I've just started pulling it apart and I've just noticed all these things. Someone's definitely played around with this. Here's another thing that's made me laugh, right? So these capacitors here, these are in parallel, all of them. Now these are old Weimar 100 at 35. These ones are 220 at 63. Did someone, and these, Sam, Hua, they're not original. Did these original ones just get so old that they don't work anymore and someone's just paralleled these in and doubled the value? I got a funny feeling this is a bit of a botch job. You can see there's a diode that someone's... Right, sorry about that. My camera just arbitrarily stopped recording. It wasn't that arbitrary. I ran out of storage space, to be honest with you. But yeah, anyway. Someone's changed that diode there. Someone's changed all of these purple looking capacitors. If you have a careful look at the resistors, you'll note that there's a lot of burnt up looking resistors that are not original. Alright, so this thing's had a bit of work done on over the years, you know, but not by a competent person. I can tell you that. Because you don't just replace capacitors by taking... I'd wager a bet, seeing that these are in parallel and they're all 100 at 35 volts and they're being replaced by 220s at 63, that someone's just doubled the values of that, removed half of it and replaced. Yeah, it doesn't work like that. But I can see what's happened here. Why someone's gone and cut wires out of it, I don't know. But I mean, I can definitely see that connection there was soldered to, and following the trace it goes to one of these 4 resistors here. I'm sure it's not for nothing. I'm sure, yeah, so there's going to be a little bit of tracing out to do, a little bit of restoration to do on this, so I'm going to do that right now without any further ado. I'm going to get this apart and on the bench and we'll start testing stuff. Thankfully it's only a power supply and it's not in some terrible condition, like, you know, short circuit somewhere, like the outputs are shorted, and half of everything behind it's all fried. Like it's not that bad, you know. It's got some sort of offset problems. If I had to take a guess, I'd say there's op amps in there that are fried. You know, they got offset on them and drift or whatever. They've just gone, like, not drift, what do you call it? Like offset, you know? And, or maybe not working at all. Some of them might be some transistors like that. Some little ones, you know, particularly these old metal can style ones. Like that black plastic metal can one, not so much this style. But, like we won't know until we start testing. You know, there's a lot of old parts in here, like these op amps that have the compensation capacitor. That's not something you see anymore. Yeah, so I'll get this teared down and we'll start testing things and see what we've got to do. But basically what I'm going to do is, my ultimate goal is to restore it to its original condition, basically. So put everything back the way it's supposed to be, fix everything that was broken, and go from there. So I'm going to get my phone mounted up here and start bringing pieces up here and clearing the bench and that, and I'll come back to you guys in a minute. Alright, I just thought I'd show you this, guys. Underneath, so I've taken the two main boards out. Actually, I don't want to keep bending that backwards and forwards, so I'll just show you this first. I've taken the two main boards out. There's a few components in the back of that one. That's the bottom board, and this is the top board that you've already seen the top of. Right? You see what I mean about the burnt areas? You can see what got hot. Not a problem, I can fix all that. That's the power supply board. So that's just a whole load of rectification. Oh yeah, that's right, it's a dual supply, yeah. I was just sitting there thinking, why are there so many rails? Oh, wow. So that capacitor's actually blown out the bottom. See if you guys can see that. This capacitor in here, look at that. No, I'm going to have to bring the phone over. Yes, that white lump is not one of the wire tags, that is a hole. See? Yeah, the whole bottom of that's blown out. I did say I'd most likely be changing them anyway. Well, I do have some good news though, because so far, as I've been going through this, I've actually come across quite a few wires that have been cut in the wire loom, wire wrap. I don't know what you want to call it. So there's a possibility that that is factory and no one has actually messed with the wiring, but I don't understand why the meter selection from amps to volts on this side has got one less wire than the master side. I get this is the slave side, but the thing is, well, when it's in parallel mode, it's not the case. They have two independent supplies. So just got to be careful with some of the wires in here. I don't rip them off as I put that back down. So yeah. Anyways, I'm gonna keep pulling this thing apart. Actually, you know what? I might be able to show you another example of some more cut wires. So on the other side, on this wiring loom for this meter selection switch, there are two wires sticking out of here too. So there's a green and a purple there, and on this side there's a green and green with a white stripe and a pinkish colour. Get down, get down, get out. Oh no, you didn't just step in there. Oh fuck. Man, what is it with cats walking over circuit boards and squishing over components? Anyways, yeah, so I'm not, oh, whoops. I knocked that clean off the pan. Wait, that doesn't look factory. Oh, I see. Yeah, no, I did knock that off the back. That's alright. I think that's been knocked off the back previously and someone's possibly done that to get it back on. That's all good. I'm not too worried about that, so it's power indicated. But anyway, I'm gonna stop moving this around to show you guys stuff, because I'm just gonna end up breaking all the wires in it and give myself a lot more work. Alright, so since that's already off, I'm just going to leave that off to the side so I don't damage it anymore. Nice. But we know we need to get decent access to this bottom board anyway, because we've got to change these capacitors. I might need to get this back bar out here also, just so I can stand this board up straight. I tell you, I'm working in a tight spot here. It's alright, I'll be alright. If anyone's wondering why I'm getting straight onto this, it's because I've got an amplifier that's taking up like almost the entirety of my other workbench, and I don't really want to work on that until I've got a proper dual supply going. I do have another brand new one that doesn't need repair that I've bought, that's on the way, but I don't want to wait another week for that to arrive, so let's see if we can't get this one sorted. Look out for that fuse socket on the back too. It's kind of wired a bit tightly, but if you're careful, as you can see, what am I breaking of mine? Meter plastic, okay. Yeah, so as you can see, if you're careful, you've actually got enough space to fold it all out. You just have to pop the panel meters out and fold it back. I don't know how much you guys can see of that. Oh yeah, you can, cool. Right then, oh okay, both these capacitors have vented through the vent hole. So I'd say that's a vent hole because it's in the exact same spot on both caps. I mean, I'd say that at one time, although no, because it doesn't look like any of these rectifiers have been changed. I was just going to say maybe the rectifiers had shorted and put AC into the caps, and someone changed the rectifiers but not the caps, but no, the rectifiers look original. Alright, well, I'm not going to waste you guys' time, so I'm just going to keep looking around because I don't have the schematics for this, so I've got to reverse engineer it as I go. I have to trace literally everything out, observe how everything's done on it, you know, work out what changes I want to make to it, work out what's wrong with it. I've got a little bit of digging to do. So yeah, I will say one thing, some of these old capacitors are going to be perfectly fine and others are going to need replacing, you know, so it just comes down to it as we get to it. Anyway, I'll be back soon. Alright, so I've got a little bit of good news. On further investigation, there actually are 6 wires going to this pot. Sorry, let me just hold my phone a bit better. I didn't see there's 2 orange wires doubled up, and if you go look on the other side, it's exactly the same. So it's starting to look a bit more promising, I can say that, but there still are a couple of wires, well, wait, didn't I find them in 2 spots? Yeah, there's some wires in this harness that run from here all the way across. Actually, I wonder if they're the same wires. Let's see, we've got purple and green. And on here coming out, we've got a green with a white stripe. What have we got here? Is that green got a white stripe on it? No. Does this green? Yes, this green does. Okay. So the green that's there just comes out there. And the pink one that comes out here comes out there. So further down here, I'm sure there was one more. Yes, there's the plain green one that comes from there. And then there's a purple one. Let's see if we can find the other end of the purple one. My apologies with the camera. I've got a feeling it's cut off somewhere around about here. And it's hiding in the loom. So, I got a funny feeling that they just had this loom made up. Wow, sorry. Just realised I was holding the phone the wrong way. I reckon they had this whole loom made up and just had extra wires in it and they couldn't be bothered to cut it out. They used it for another power supply or product or something. I could be wrong, but I'm going with that for now. Yeah, I mean, everything seems to check out. Also, actually, that is a bit odd. Well, that looks factory too. I just realised that the independent and auto tracking series parallel, whatever you want to call it, switch has a couple of resistors by the looks of it inside, some sleeving going up to the constant current set pot. But on the other side there's nothing going to that one. But there again, that is the series parallel switch, so it could just have something to do with the fact that when that's down on auto tracking, these two controls become the master controls. I don't know. I just find it weird that there's a resistor going to that, which I would imagine the constant current pots would go to the constant current circuitry or to a reference or something like that on one of these boards. But anyway, I'll continue tracing everything out. As you can see, it's a bit of a rat's nest, but it's a beautifully laid out, neat rat's nest. So I'm quite happy to be working on this. But now I've traced out all the wiring and I'm pretty well content, other than the fact that it looks like there was one wire soldered there. I'm going to try and work that out and see if I can work out where that's come from. Have a good look around here and see if I can see a wire that's been cut off or anything different that's on one side to the other that doesn't have something to do with series and auto tracking. I mean parallel versus auto tracking. But yeah, alright. You guys won't see much more wave around the camera with the camera because I'm going to mount the phone up here. Now I've got all the boards and everything out. I'm just going to quickly go over, like I was saying a minute ago, those diodes and caps and change these two caps, and then I'm going to put that back in, pop the meters back in, and we will mount the phone up here and get to work on the boards. So we'll be back in a minute. Alright, so first thing I'm getting started on, I've tested all these diodes by the way and they're all good. These caps are across the diodes, so they're obviously not shorted, and given their form factor I can guarantee they're good. Anyways, I've got a couple of 4700 microfarad 63 volt caps here. These are only 2500 microfarad each. So what I'm going to do is I'm going to get the data sheet for these diodes, the main ones that charge up these filter cans, and I'm going to work out what the peak current is charging up a 63 volt 4700 microfarad cap. I'm going to work out what the peak inrush current is on that, at whatever voltage this is. I think it's 45 volts or something in that ballpark. And then I'm going to work out if these diodes can handle the inrush current. If not, I might put some bigger diodes in there, or I might just get some smaller capacitors. But what I am going to do, because the only way I could really mount the capacitors as they are would be to sort of bring the wires out, stand the capacitors upside down, and attach the wires from the top. And let's face it, it's ugly. I could securely mount them down, glue them or something, but it's ugly. So we're going to restuff the cans. So without further ado, I am going to start removing these cans, and I'll bring you back to the bench. We'll start disassembling the cans. I've just got to quickly look up the data sheet on these diodes and do some calculations to make sure that these are the caps I'm going to be putting in there. Next thing, I've been thinking about these boards. The entire thing is based on LM301 ANs. These are the old school op amps that you need a compensation capacitor for. I forget what you can swap them with, but I think any 5534s, TL072s. There's a few parts that might not be pin to pin compatible. I'm not sure. I haven't looked yet. Got to get the data sheet and just see what that says. But there's a good chance those, and there's usually an extra capacitor and resistor sometimes too as part of the compensation network for them. So that might all end up coming out and getting replaced with, say, 5534s or something like that. But at the moment, that's all I've decided on basically. What I'm going to do is I'm going to go over all the diodes, test all the transistors, because there's not many. There's only 8 transistors on this board. We know the output transistors are good, so we don't need to test them. Well, I mean, I guess one channel could be leaky, but I highly doubt it. But anyways, yes, so there's another 2 transistors on that board too. And what are they? Okay, they're 2N2270s, the other ones are 2N4356s, and the little ones are BC107Bs. So all of those transistors are easily substitutable too. And I haven't studied the circuitry yet, because I can't imagine that they'd be using to drive 2 3N055s, 30 volts, 1 amp. I can't imagine that these are the drivers. I'd imagine that they're using these or something to drive. So maybe I'm wrong. I haven't studied the circuitry yet, but I'd be more inclined to think that maybe that's sort of some sort of shunt regulator for when you turn the voltage down, so it pulls it down quickly. I don't know. Like I said, I haven't reversed the circuitry yet. There could just be a simple resistor across the output, which could be these 2 resistors that get really hot. There could be some sort of voltage pull down shunt circuit. That could be why these are there. I don't know, but I find it interesting that they got heat sinks and those are being used. If they are being used to drive the output, I'll check the gain on the output transistors, and if it's fairly high for what they are, I might even substitute these with something that's a lot smaller and has more gain, and keep these for something else, because that's a whole, I could literally mount those 2. They're perfectly matched. They're from the same batch. They're both Farnell 2N3055/A 219 at the bottom, so they're probably quite closely matched. I could use them in another power supply build or something for the series pass element. But anyway, I'm just wafting on here. I might end up leaving them in there, who knows. Depends, like I said, depends what they're doing really. I also just want to point out, I took one of the outputs off. I'm not going to take it off again, but oh no, there are emitter resistors. For a minute I thought that they just had wired them literally in parallel. You know what, I think the bases are in parallel. I don't think there's base resistors. I might end up changing the topology on this just a little bit, you know. I mean, we do have better ways of doing things now. Let's just have a quick look. But like I said, I intend on making this look original basically still, but I want to increase the performance of it as much as I can. And I'm not necessarily talking about the voltage output or the current output so much, but I'm talking about the transition time, you know, rise and fall, fast setting response times, you know, the line and load regulation, stuff like that. Okay, so the collectors are commoned up, the bases are commoned up, there's no base resistors, just the emitters go to resistors. I mean, if they're perfectly matched, you know, and it's only passing an amp, that's fine. Even if one's doing a little bit more work than the other one, they're going to be well within this safe operating area. 2, 3 and 05, 2 and 3 double fives to do 30 volts at 1 amp is overkill. I mean, it's only a air-cooled heatsink, but it's still a pretty chunky heatsink, and there are 2 of them on there. So even if you left this on all day at 30 volts at 1 amp and got hot, they'd still be well within their safe operating area. So I don't know, I might end up adding base resistors at a later stage, I might not. I'll do some tests and I'll see. Basically what I'll do is, when I do end up fixing it and I've got it running, I'll do a measurement across the emitter resistors with the power supply loaded down, and if, you know, one of the emitter resistors has got more of a voltage drop on it than the other, then I'll go and stick base resistors in there to even out the current flow between the 2 devices a little bit better. So yeah, a lot of things that I'm talking about I've got to go and do my investigation on first, but I just thought I'd bring you all along for the ride and explain my methodology and reasoning for the things that I'm going to do. For those that are wondering, building power supplies and amplifiers are 2 of my most favourite things. So this is one of the departments I'm a nut in. So this is right up my alley. Alright, well, I'll leave this bit here. I'll be back in a moment. I am going to get these cans out. Actually, I'll look up this data sheet first. Make sure that I can put 4700 mics in there. I'll be back in a moment and we'll see what we're going to do. But either way, we're restuffing the cans because I want to keep the original cans sticking at the top. I like the look of it. And you know what? I might actually no, you know what? There's no point in restuffing the cans. You know why? These will fit in here. I can just disconnect these cans and just heat shrink these in there, and they can just sit in the bottom. Heat rises. It's going to be cooler in the bottom anyway than sitting next to this big transformer. I'll do that. We don't have to restuff cans, but the original cans will still be there, so that's good. Yeah, I'll do that. Alright, well, I'm going to pause the video, look up this data sheet quickly, and I'll be back in a minute. Alright, I'll just give you guys a look. I just got the data sheet up for the diode. It has got insane ratings that I am actually shocked to see. But apparently it can do 6 amps. I find that hard to believe, but I've had a look at the graphs, and yeah, you should see the surge current ratings on this thing. So the point I'm getting at, this diode's not going to have any trouble charging up 4700 microfarad caps. So that's what we're going to do. That's the first thing that we're going to get started on. Let me just get you guys a bit better focused. There we go. So we'll get our soldering iron. Solder over here. And start getting these wires off these caps. Okay. I'm just going to blob them up into one big bunch for now. Like so. And that can just sit over there. This insulation doesn't like the heat, but because it's wrapped around the tags, like J-hooked, it's basically impossible to get it off without heating the shit out of it. But that's alright, because I'm just wrapping them together and giving them a bit of a twist and then blobbing them up, and then I'm going to hook that up, solder that to the capacitor legs with a couple of layers of heat shrink over it, so it's going to be perfectly secure. I'm not worried about the insulation coming off. And crappy wire. I think what I'll do, since it's so messy, is I'll just get a few bits of heat shrink just initially over just the ends. Just to re-insulate the insulation that's coming back on me as I'm soldering it. Because there's not enough wire length here for me to just cut it shorter, you know. And I really don't feel like undoing a whole load of wire wrapped wire loom and remaking it up. No thank you. Alright, so that's positive and negative for one capacitor. I'll just get the other one out now. Let my solder go. Sorry if this is going to be a long video, but I'm doing a complete restoration on this and it is going to take some time. I'm probably going to want to change things around in here and make things better, which is going to take time also. So if that's not what you're into, I'm sorry, but My channel's going to have a lot of different types of content on it. It's, you know, sometimes it'll be little videos that aren't very long, other times they'll be ridiculously long. Sometimes I'll be fixing something, sometimes I'll be making something, you know? So, some videos might not be appropriate for some people, but other videos you'll love. So just give me a chance and have a look at what different things I put out there, and watch what you like. Don't watch what you don't like. Geez, I tell you, we're working with tight clearances here. I don't know why the wires on this side aren't, sorry guys, I don't know why the wires on this side aren't stripped as much as they are on the other side. Well, I know why, it's because back in the day everything was built by hand. Yeah, rightio. That meowing is the same cat trying to have, I don't know what you want to call it, attacking all my other cats, trying to have a fight with them. She's gone mental lately. One of my cats had kittens, and one of the other cats decided it was going to try and mother the actual mother's kids, basically stole her kids. Then she started getting the shits at all the other cats. Well, sorry, no, at first she started getting the shits with the actual mum, which was weird. And now she's getting the shits at just all the cats and just going nuts all the time. She's off a rocker. I'll tell you, it is getting to be a problem. If I can't get her to settle down, I might have to like give her away or something. I can't. She's gotten pretty crazy. She's drawn blood on my cats. Had to cut her claws meticulously all the time. It's gone mental. And I don't have a clue why. My third hand is sometimes my mouth. Yes, I know, I shouldn't put leaded solder in my mouth. Probably shouldn't do a lot of things I do. Alright. I'll just bend those old tabs in so they're not in the way. And I think what I'm going to do, I'm going to sneak one capacitor underneath that. We've got enough clearance in here, yeah. Oh yeah, definitely. Okay. Oh, I've got plenty of clearance. I just want to make sure I've got enough clearance for the cap and the wire loom if I do this. Maybe I won't. Maybe I won't put that there. Don't want to bend that too much anyway. I want to keep it sort of away from the transformer as much as possible. So this one's easy because it's all the way over here. Yeah, I don't know where I'm going to stick that. Can I fit it there? I could. Yeah, I think that's what I'm going to do. Tell you what, someone's been in here before, unless it was the factory, because there's bits of solder all over everything. Anyways, I'm going to put that capacitor there. How am I going to get heat shrink on that part? It's a tough one. It's a bloody tough one. So easy to fit this one here, but that one, there just really isn't much space. I think what I might do, go back to my plan A, stuff this under this Transformers harness, take this, very carefully without knocking everything off. Put this back in. And no, that doesn't fit in there. I had a feeling that would be the case. If anyone thinks I'm being rough, don't worry, trust me, this shit is solid. It's not made like things are made today. You know, when I get this thing up and running, I'd literally be quite comfortable to take this outside and drop it off my one-story house roof onto the grass. With it plugged in, turned on, I'd almost bet my life on it that it would still be working. Good luck doing that with something these days. I think I'm just going to have to mount it like that. Maybe I can wrap the capacitor's legs, because they're brand new caps, they've got legs around my exposed bit of solder all that up and then slide some heat shrink over it. Let's see. I guess. Sorry if that bang was a bit loud, guys. I guess it's doable. Is it ideal? No. Is it a solid connection? Yeah. I guess that's what I'm going to do. I mean, it's not like visually it's going to matter because it's in the bottom. You never see it. The original cans will still be in the top. So it's just going to look original. Yeah, I'm actually quite happy with that. I don't know how that looks on camera, but it's actually quite good. If it doesn't look good, I can tell you now, it's actually pretty solid. Where's my scissors gone? Well, I'm very pleased with that. Doesn't look like go anywhere. Might put a cable tie in here. Oh, I can actually move a bit of this loom. Yeah, there's plenty of give in that. Yeah, so I can leave that like that. That's perfect. I'll just get a cable tie. Well, I'll get 2 of them actually because we've still got one more capacitor. Technology, eh? The cap I just put in there is twice the capacity and the same voltage rating as the original one, and it's a quarter of the size. I've got to go buy some flush cutters because I broke those flush cutters in that video. Well, one down, one to go. And this one's going to be easy because I can stick it anywhere. I'll just cable tie it to that, that'll be fine. Yeah. Yeah, I'll just cable tie it to that. Alright, how do I want to do this one? I think I'll do the same technique. So I keep putting that down absent-mindedly, really loud, not thinking about how loud that probably is on camera. My apologies. Soldering iron's gone to sleep. Soldering iron's back up to temperature. Alright. Sweet. Yeah, I'm just going to put that there. It's never going to get moved anyway, it's just going to sit on my bench. I guess that'll stay there and this will just rest on the bottom of that. I'm not worried about it. It's not moving any wires that go to solder joints, so it's not like it's going to rip solder joints off and its own wires can't come off, so that's fine. I'm happy with that. Well, that's all that section cleared. So we don't have to worry about the power supply finally. Front panel connectors I've tightened up. The panel meters I've zeroed out. I'm just thinking. Oh no, I tested them before, that's right. The 100 millivolts full scale. I zeroed them. So panel meters I don't need to do anything with. The pots, they seemed alright, honestly. A little bit old, but they might come good with use. I can tell you now, the two Duncan pots, I can't take them apart to service them. Only the genuine Hybridron ones are made by Spectral, well that's what they call it now. What are they? I forget the brand, Bournes. Those ones I can pull apart and get contact cleaner in and clean them out. But the Duncan ones are sealed and there's no way of getting anything in there. Not if you ask me. I mean, you could drill a cheeky little hole somewhere, but yeah. The only thing is they're 500 ohm pots. Let me just go pause the video and see what I've got. Yeah, I've got V-Shape Spectrals, and I've got 5Ks, 10Ks, and 20Ks, 50Ks. So no 500 ohms. These the constant voltage pots. They're Bournes and they're 20K. Hey, is it 20K? I thought, what was it? 5K, 10K, and 50K. Damn it, so I don't have them either. Who knows, a 50K might be fine in there. But I'd rather leave it how it is. Alright. What's next? I guess put this back in. Got nothing more to see on here. God, this is a bloody mind game. Trying to get it in without squishing anything. Yeah, that works out nicely. I'm more than happy with my capacitor placement. Alright, so that doesn't need to come out anymore. That's the power supply service with new caps, and the original one's still in there, or looking like they're still in there. Panel meters. These are a bit tricky. Bit of a tight fit. Oh, that's one. That's the other one. I'm going to pause the video because I've got 2 of these brackets, 4 washers and 4 screws to put on, and I don't want to waste your time watching that, so I'll be back. Well, I just wasted my time. As I was doing up the screws here for these, sorry, the bolt nuts, whatever you want to call them, for the panel meters, I just realised there's still one more thing that I had to change. Why do I have a screw sitting there? Oh, that was that long one I put to the side. Oh, good. I know what's from. The output capacitors, I'm changing them, of course. And guess where they're situated? I don't know if you can see. I'll show you guys in a sec. But great. Where did that go? Oh, right there. Good. Alright, unfortunately, I'm going to take those back out again. Because there's the output capacitors, and to be honest, I think it'll be easier if I even just lift the top up. Yeah. I think I want to lift the top up. Actually, you know what? If I cut them there and there, I'll have all that lead on each side to wrap my new capacitor on and then solder it. Do I want to do that? Not really. Oh, it looks like I can actually just take them straight off the tags right here. Yeah, sweet. Okay. We can actually get to them where they are. Beautiful. I'll just move you guys in for a little bit of a better view. Sorry, I'm just trying to get stuff out the way so you guys have a view. There you go. Alright. So, I think they're 150 microfarads at 63 volts. I'll just pause the video and go get replacements. These are 100 microfarad at 63 volts, low ESR caps. I'm going to put 2 of them in parallel. That'll make 200 microfarads at 63 volts, low ESR. Even lower ESR because there's 2 in parallel. I'm going to use them with a 1 microfarad monolithic 50 volt capacitor. Those 50 volt monolithic capacitors are usually alright. I'm not saying you should ever use one at 60 volts, but I'm just saying if it goes up to 60, 65 volts for a minute or so, usually nothing happens. So should the output fail, the driver's circuit fail, or the output short or whatever one day, and that condition happens, I should have time to turn it off before the capacitors get destroyed. And the electrolytics won't anyway. But this thing didn't even have any high frequency suppression on the output. It literally just had 150 microfarad electrolytic. So I can improve that by a bit. Like I said, I want the noise level on this as low as possible. I don't know what it already was. It probably was pretty good. It's going to be better. So, work out how I'm going to get these on. I think I'll pause the video whilst I make up these and then I'll come back. Okay, so I've made up my capacitors. Like so. Let's take these out. It looks like they're just soldered directly onto the lug, not even wire wrapped around it. But I'll know in a second, won't I? Oh no, they are J-hooked, I think. Is it J-hooked or it just goes through the hole? Yeah, they're J-hooked. Okay. That's alright. What I'll do, I'll cut them out right at the bottom. Right where it solders to the tab. Leaving nothing but a small J-hook on the tab. And yeah, everything that I pull out of here that's not leaking, we'll do a video later on and test to see the condition of all these ancient parts. Because whenever I end up with old parts that are still good, I put them to the side. So when I want to do some really, really old, oh my God, get out of here. No, 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 no. That's not a toilet. Get out. 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 Bloody cats. When I want to do like some sort of old school build and I want old components in it, well, I have a little selection. So I want to build some old tube amp or an old radio or some whatever, you know, and I want age appropriate components. So yeah, we'll go through everything that I pull out of here, we'll test it, and what's good we will keep. Right, so these are just gonna, yeah, I've just soldered them straight onto those tabs. I'll just cut that longer lead a bit shorter. Can you stop? Hurry up, my cats are going bonkers. Alright, I'm happy with that. Let's get a nice thick blob of solder on this tab. Freshen it up. Some new solder. Sorry, on both of these tabs I should say. Yeah. I should probably do that one first because I don't think you're gonna, well, you'll probably still be able to see. Should probably just do the one that's further away from you guys first, I guess. I don't know if it's going to be easy to see or not, but beautiful. Beautiful. And they can just get folded up just a little bit like that, and they can live there. Well, actually, they'll be in the way of the panel meters, so I'll put them like that. There we go. It should be good, as long as the panel meter still fits. No, mine like the panel meter won't fit, and I'm going to have to mount them in some different orientation. Let's see. Have I screwed myself? This panel meter coming. Oh, you gotta be kidding me! They're like literally, it just holds in there. That's perfect. Well, I wasn't expecting that. I thought that was going to be a little bit too tight. Okay, so in the next one, I was just having a look just then, just a cheeky little look to make sure I put them around the right way. Electrolytic capacitors don't take kindly to being installed backwards. So, like that. Cool. Now we can pop these panel meters back in. So, I should now be up to the boards. That should be, everything in here should now have a clean bill of health. Let me just make sure that these panel meter connections are done up tight. Quarter of a turn they need. Okay, I've got to clean these edge connectors too. I'll pause the video whilst I put these brackets in, but just before I do, I just want to point something out. For anyone that tries to put these meters in, the way the bracket holds them in is a washer and a nut on each screw, and this clips down like that, right? And it holds the meter in. But good luck getting the screw on with this tension. So what you do is you put the meter in, and you take this, and you push it through the front like so. Sorry, it was meant to be on the screws, but you push it through the front like that. And you see now, you can literally just pick up your washers, slide them on there, get your nuts, and you only have to do them up finger tight. You don't even need to do them up all the way. I'll show you why. You'll understand why in a sec. This is basically a spring. These nuts are just holding a spring, and as soon as I pop this back out, they're under tension. Goodness. So you just do them up as much as they do up, basically, without using ridiculous force, whilst holding the spring down. And then you grab something like a pair of tweezers and you pull the spring back out. I don't know why this is not coming out. Okay, there we go. Then you pop it back down. You see how, I don't know if you can see that. I'll do the other one because it's closer to the camera, but this top bit of metal stays up and the two bottom bits click into place, and now that panel meter's stuck in there, it can't come out. So I'll just do one more. I'll do this a bit neater than I did that one. So you put it on and press that down and slide it out the front. Get your 2 washers. You can pick them up off this bloody rubber mat. Right. Click them on. Get your nuts. Get them on. Then this clear, pull it back out like so, and then down, and it just pops in. That's your panel meter locked into place. Alright, filter caps, diodes are tested, all the front wiring sorted. I'm not touching the pots for now. Output capacitors are sorted. We've got to put this bulb back. I'll just use some glue to fix that. Yeah, I'll just glue that together because the front's coming out too. That's fine, I'll glue that together. Edge connectors. So these are something that I do need to clean first. And then once I've cleaned those, we can say that the this part, the power part, when I say power part, I'm basically saying the output stage and the power supply itself, like the transformer, diode, bridge, filter caps, all that sort of stuff, the front panel, everything that's in here now has a clean bill of health. So what I'll do is I'll end this video here. Well, before I end it, what I'll do is, hold on, let me just find the washer I need, sorry. What I'll do, I'll do the edge connectors first, we'll clean them out, and then I'll end this video as, say, part 2, and then we'll do another video on the circuit boards, start working on them. Although, you know what, I'm not tired yet, so I might continue working on this for now. Maybe I'll make this video a bit longer, who knows. We'll just have to see. Cool. So, I'll go get a brush, I'll be back in 1 sec. Alright, I'm back. So I've got a few different things I could clean this with. But circuit board cleaner is different to cleaning solvent. Although cleaning solvent and IPA are good, this will actually clean the copper up. And if it doesn't, we might have to use something a bit harsher. But we will try with this first. Oh, I'm seeing shine come up already. I think you guys might be able to too. It's only a little bit, it's a slow process. Yeah, they're coming up. I really want to clean the edge connector out because I really don't want to have to solder all the wires to the board. That'll just suck. I mean, it's not that it will suck doing it, it's just going to suck if I ever have to repair it when I go to pull it apart. I won't be able to just take the connectors off, take the board out, you know, I'll literally have to unsolder all of those wires on each connector. And that won't be fun. I'll pause the video whilst I do this because it's a slow process, but as you can see, it's coming up. And I'll come and show you when it's finished. Oh shit, you can't even see right now. I'm a dumbass, I've got a can in the way. Sorry guys. Yeah. See? Starting to get shiny. I'll just pause the video whilst I keep going at it. Alright, so that's one edge connector cleaned up. It still looks a little bit black on those leaf spring sort of things where they go out, but on the inside where I've been putting the brush in and out, and I used some wet and dry sandpaper plus the cleaner, I can tell you looking in there it's beautiful, like brand new, where it needs to be. I am actually noticing something now. The end contact, the pins have been bent down. Now I have seen this when the brass gets really old, it loses its tension. I think this has just been bent. Yeah, I'm really not happy about that. The rest of them are all nice and tight, but the M1's got about 1mm gap through it. If I put my tweezers in there, which is a bit thinner than the circuit board, but still it doesn't feel too tight. Got a piece of circuit board right here. Yeah. I don't know that I like that. Guess there's not a lot I can really do about it either. Unless the pins come out. No. Oh. That fixed it. Oh, I see. So I must have had it pulled back because as soon as I just pushed it forwards then, it's tight together now. So, sweet. So that's one done. This one's twice the length, unfortunately. So I'll pause the video again, I'll clean this. And, yeah, I'll come back in a minute. Alright, so I've cleaned up the other edge connector now. Again, same thing. I can show you with a light probably if you see right in there. See how it's all nice and shiny. It actually makes contact. Even the dark ones. You see? It's just the outside. It's still hard to see on camera, but trust me, the actual bit where it's close together, where it wipes, it's beautiful. It's all nice and clean. The other thing I wanted to do is I wanted to clean out the pots. But the pots were functioning alright anyway. One seemed a little bit funny, but it was alright. But then the way the voltage circuitry is working, you won't be surprised that the pot's perfectly fine. In saying that, 2 of the pots you can't get into anyway, and the switches, there's no way to get cleaner into them. So, oh yeah, I could pull them apart, but the switches are working. There was no problem with the switches. So, that being said, actually I can get contact cleaner into these 2 switches. Hey, get down! You can't come in here! Fuck, they don't listen. Alright, let's... Actually, I'll get a tube on this so I can get it in there. I don't want it. one. Okay, that's all I can really get at. Like I said, the switches were working, the connectors that were loose, I tightened them up, and the pot's already working too, so that means this piece, unless the only other thing that I noticed on this that I was a little bit suspicious of was the fact that one of these tags has got solder on it. Now, it looks like someone just put a wire there. You know what, I'm going to just peel back one of these bits of insulative tape so I can see what the factory soldering looks like. Because I've got a funny feeling that when they were building it, someone... Yeah, it looks real similar. I got a funny feeling when they were building it, someone put a wire on the wrong post, realised, and then took it off and just moved it across, you know. Because, let me count all the extra wires. 1, 2, 3, 4. 1, 2. 3, 4. Did I find purple in here? Yeah. So the 2 wires that come out here and here actually end here and here, and there's only 3 connectors there, and there's nowhere for them to connect. So that was factory. So I'm lucky there, because when I first started pulling this apart, I was swearing because I thought someone had actually screwed with the wiring, and I was like, yeah. That's the one thing I hate. You know, if you don't know how to work on something, don't go and hack it. Just leave it, you know, because it makes it terrible for the next person like me that actually does know what they're doing. When I go to fix it and you've gone, not you guys, but someone else has gone and butchered a whole load of wiring, you know what I mean? It makes it hard for me. So, luckily that wasn't the case in the end. I'm just getting some contact adhesive on the bezel first for the power indicator. And once I've got that in, I'll come in and glue from the back the actual light itself. So that's the bezel in place. Oh shit, contacts and that's going everywhere. This stuff can be messy. Not can be messy, it is messy. Just want to get some around this. Not in it, but around it. Yeah. Try and stick a little bit around the edge of this too, just for good measure. Just make sure it's all in there, you know. It's only contact adhesive and it's only a neon indicator. Doesn't matter if it's a little bit messy, as long as it's in there and shining out the bezel out the front, I'm happy. There we go, beautiful. I'll just bend these wires back so it's actually holding it in place whilst it dries. Like that. Yep, perfect. Alright, that's our power indicator back in. So that's everything for this, whatever you want to call it, the chassis, the power supply for the rest of it, and the front panel and all that. That's all sorted. My front panel meters are zeroed. I did that earlier. So I'm just going to turn this around because it takes up space. Yes, I end up taking those caps off these because these are series pass elements. They're both in parallel, so there's no voltage between the two. You can't short them together. The only thing you could do is short them to the heatsink, really, and I'm not an idiot. I'm not going to do that. I'd rather have them open to the air so they can cool better than bloody have caps over them, you know? Maybe if it was like an audio amp and it had a push-pull output and like 100 volts or something across it, I'd be more inclined to worry about the insulators, but all that glue's not going to come off. But yeah, for this, no, I'm just going to leave them off. More cooling, why not? So I'm going to move the phone now. My apologies if that's a little bit annoying. Now let's have a look at these boards, hey? See what we've got. So, first things first, I want to know, the tantalum's shorted. There's only 2 in the entire supply. No. No. Well, that's good. Now, I don't know why these 2 specific diodes have an air hole cut underneath them. That's interesting. Do they get hot, or are they using them as a Xeno reference or something? Let's just see with the crappy component tester. This thing does come in handy for some things, but if it's something important, obviously I'll be using the DCA. Oh, I'm a dumbass sometimes. Just hooked it up like a normal diode. No, wait. I had that right. Okay, so it's not a Xeno. Shouldn't be anything this way. Oh, what? That's probably just a volt drop from something else in the circuit. I don't think that's a Xeno. Let's see how the other one reads in that direction. 2.9, yeah, I don't think that's a Xeno. I already don't like the fact that there's 2 different voltage drops across it. That's already indicative of stuff being out of balance in the circuit. Obviously I'm going to change these capacitors, but I'm just curious, do they have any resistance across them? Yes, but that again could be resistors. I'd say that's resistors. Alright. Just out of curiosity, what do they actually measure as? I can't be bothered using the LCR meter for this. About 300 microfarads. Oh, that's not good. They're only supposed to be 50 microfarads, so the fact they've gone up that much means they've dried out. The ESR would be through the roof, so they've got to get changed. So we've got 4.7s at 75 and 50s at 35. Alright. I'll get on to that. Ah, that's interesting. So the LM301s, I'd say 2 of these would be for constant voltage and 2 of them would be for constant current. But look at this. It's as if someone's had to change exactly 1/2 of them. You know what, that soldering does look factory though. Yeah, hardcore. Well, I'm not too worried about anything on this board. I'll check over the diodes quickly. Make sure there's no pop diodes, and I'll change the capacitors. I'm not going to change any op amps just yet. What I'm going to do is I'm going to look over both the boards, fix anything not including op amps for now, power it up, see if it works or not. If it doesn't work and there's still meter offset problems and stuff like that, then we'll start looking at the op amps. I want to preserve as much of its originality as I can. Although I wouldn't really mind putting newer op amps in it now that I think about it, because it's... Wait, did I retest these? Didn't I? Because it's obviously going to improve the slew rate and the bandwidth and the response of everything. The constant voltage and constant current circuitry response. So... these are different. These are UA301As. Oh! Hey, look at that. That's an LM301. Oh, UA301. Yeah, same thing. Just a different manufacturer. I am starting to get tired now, guys. I don't have my bloody head in the way again, do I? You know what? If I move this back more and start doing everything like that, that should solve that problem. Alright, well, I wouldn't be half surprised if I got to change all the op amps, but for now I'm just going to bother with the capacitors. So this board, for starters, I'm going to change capacitors. I'm not worried about changing resistors, although it is interesting because I wonder if these newer looking resistors are factory or not. Going by the oxidation on their legs and the solder, oh, no, yeah, someone could have changed them. It's hard to say. It's just all the resistors, most of the resistors in here are this style. So I just find it strange that there's just these couple random sprinkling of other style resistors. And especially these ones here that are burnt up. I reckon someone's changed them because the previous one's burnt up. Yeah. That makes me wonder. Alright, well, I'm getting tired, so I'm going to end the video here. I'm just going to test over all the diodes on this board quickly. And measure these big resistors. I'd say these are discharge resistors, and I don't know what they're doing. And oh, they're shunt resistors, I think. They're like 1 ohm. Oh, what are these? 0.6 ohm. No, those are the shunt resistors. 1 ohm. Don't know. Anyways, good. 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 That diode's different too. Oh no, it's the same as those two. Oh, okay, so these two are different diodes to all these other ones. These other ones are BZY 88s and BZY, sorry, OA 200s. This says C3V6. That might be a 3.6 volt Zener. Be interested to know. I'm going to find out what these diodes are, because I don't know if they're relying on the forward voltage drop or some characteristic of the diode to make the circuit balanced, some part of the circuit. So what I'm going to do is find out whatever the best replacement diode is, and I'll replace all four of those with the same diode just to keep everything symmetrical. Yeah, I realise some of the shit I do is overkill, but I like to do stuff properly. I like my stuff to last, and I like to have confidence in my work. You know, like when I work on something, I want to know it's going to keep working. Alright, let's see what these resistors are doing. Yeah, well, these are supposed to be 1K. And they are. These are supposed to be maybe 10, maybe 1. Can't really read it. Yeah, 1. They're both perfect. Yep, put the 0.6 ohms. Look, everything shunt wise. Yep. Alright. So I'll just show you guys something else quickly. If you look, those capacitors are literally pissing out their acid. These ones are pissing out their acid, electrolyte. So, yeah, I'm going to leave that for here, for now. What am I saying? I'm going to leave that here for now. I'm just thinking these capacitors, these are all in parallel. Okay, they're not. Interesting, they're not actually in parallel, but okay, someone's done something here because there's empty holes. What? What? Maybe there used to be capacitors on the back of the board here, hanging down, as well as these. Actually, yeah, that makes kind of sense. Maybe they had 135, 135, then another 135. Hey, these little ones are only 100, and these ones are 220. You know the thing that annoys me about this? I don't know what values are supposed to actually be there. So that sucks. The ones that are 220, what are they going to? some of the resistors get really hot. And the 100 ones are also going to resistors that get really hot. They're all going to the same resistors. Makes me wonder, because these have to be replacements, and why are 220 and 100? Are they the correct values? I don't know. I'm gonna go to bed now because I'm getting tired. But I'm gonna do a quick Google too and see if I can get some schematics on this, because I haven't been able to find anything on this. If anyone out there knows anything about this supply, feel free to reach out to me and let me know where to look. It's a Scientific Electronics model 612B, I think. Yeah, 612B. Scientific Electronics model 612B. Yeah. Alright, well, that's all for now, guys. I will see you in the next one. What I'll do for the next one is I will prepare all the components and everything that I'm going to change on here, and then I'll start recording when we actually start doing the work, just to save some more time again, because I probably waste a bit too much time talking in my videos. I've got to get used to just working a bit more than talking, I guess, but it's alright. I'm kind of new to this, I'll get there. I'll see you in the next one, guys. Thanks for watching.